this is Build or Bust, problem sheet 1, question 2. A loudspeaker cone sounding a pure note of frequency 2.5 kHz executes a simple harmonic motion of amplitude 2 mm. Question A asks the maximum speed of the cone. So the first thing you've got to do is write down the values that you've been given. So you've got 2.5 kHz, which is 2.5, and kilo is times 10 to the 3 hertz. The amplitude is 2 millimeters, so in meters it's 0.002 meters. To get the maximum speed of the cone, we're going to use the equation V equals minus A omega sine omega t. So you've got omega equals 2 pi over t, because we need to find out what omega is. So t equals 1 over f, because we've got a frequency, so we can then find the time period. So you've got your 1 over your 2.5 kilohertz, so 2.5 times 10 to the 3. Equals 4 times 10 to the minus 4 seconds. So that's the time period for one oscillation. Now that you've got t, you need to find what omega equals 2 pi over t equals. So you've just worked out what t is. You've got 2 pi over your 4 times 10 to the minus 4, which equals, which gives you omega equals 15,707.96, or 5,000 pi as an exact number. That is radians per second, or rad s to the minus 1. So you've got your omega, you've got t, and so now you're going to use V equals minus A omega sine omega t. So you've got your minus 0.002 times omega, which you've just worked out in radians per second, times sine omega again times t, which you worked out earlier, of 4 times 10 to the minus 4. Don't forget the minus, otherwise it'll be the wrong way. It's really useful to write out all your equations and all the steps that you do, because that way, even if you get it wrong, A, you'll pick up some marks, and B, you can see where you've gone wrong. Like if someone didn't convert to meters or whatever. So that gives you a velocity of 31.4 meters per second. Which is 10 pi is an exact number. 2b says the maximum acceleration of the cone. So because we've started a new page, you might want to write out your values again, but it's not essential. So A equals minus A omega squared cos omega t, which is the speed equation but differentiated again. And you've got t equals 0. because that's your maximum. And because t equals 0, omega times t is still going to be 0, and cos of 0 gives you 1. So the equation simplifies to minus a omega squared. So that's your 0.02 times your 15,707 squared. That gives you an acceleration of 4 times 10 to the 5 meters per second, or meters per second squared. Part C says the mean power required to maintain the cone's oscillation if the mean damping force is 3 newtons. So with this one, what you've got to remember is the amplitude is 2 millimeters. It's how many times of that amplitude you've got. So obviously if you start at neutral and then you go to the maximum right amplitude, that's your first 2 millimeters. But then you've obviously got to go back to the middle, which is another 2, then up to the left, another 2, and then back down to the middle to finish the cycle. So overall you've got 8 millimeters, which is obviously 0.008 meters. So the total distance equals 8 millimeters, as we've said earlier. So we're going to use the equation power equals work done over time. But we need work done, which we don't know yet. So work done equals force times your distance. To get the time, because we've got power equals work done over time, so we know what work done is going to be, but the time is, we're going to use 1 over F again, which we've already worked out as 4 times 10 to the minus 4. So power equals 3 newtons, which is your force, times 8 times 10 to the minus 3, which is your 8 millimeters that we worked out earlier, over the time it took. So the time for one oscillation is 4 times 10 to the minus 4, which is the t that we worked out just up to the right. All that, when you put it into your calculator, gives you 60 watts of power required to maintain the cone's oscillation. The mean damping force 3 newtons.